Hey guys, so really quickly today I'm just going to go over the law of conservation of mass. Basically, I'm just going to go over the background and then the pre-lab questions, and then that's it for the conservation of mass. Okay, so the background, Antoine Lavoisier formulated the law of conservation of mass, which states that matter cannot be created or destroyed. Okay, so what happens during a chemical reaction is the bonds of the reactants are broken and the atoms are rearranged to form new substances. Because matter must be conserved, the mass of the products must be the same as the mass of the reactants. Okay, that's the important part of the law of conservation of mass. Whatever mass you start with should also be the same as the mass that you get as your final product. Okay, so in this lab you will verify the law of conservation of mass using the following reaction. Well, we can ignore that part because we actually used a different equation for our lab. Okay, so let's just go ahead and take a look at our pre-lab questions then. Okay, so in the above reaction, 2.6 grams of sulfur reacts with 2.0 grams of oxygen. How many grams of sulfur trioxide are recovered? So first off, our problem already tells us that we have 2.6 grams of sulfur. So I'm just going to write it above it. So we have 2.6 grams and we have 2 grams of oxygen. Okay, and it's asking us, well, how many grams of sulfur trioxide were recovered? So this is going to be our unknown mass. Well, remember, according to our law of conservation, whatever mass we started with, the mass of our reactants, has to be the same as the mass of our products. Okay, so basically we can rewrite that equation as a algebraic equation. So we're going to have 2.6 plus 2.0 grams, that's our reactants, and it's going to equal our product. So we can label that as X. So basically 2.6 plus 2, well, that's 4.6 equals X. So we end up with 4.6 grams of sulfur trioxide. Okay, that's going to be the law of conservation of mass. Okay, so it's real basic algebra. Okay, so let's go ahead and take a look at number 2. So in the above reaction, excuse me, so in the above reaction, 5 grams of hydrochloric acid react with 2 grams of magnesium. 3 grams of magnesium chloride are recovered, and how many grams of hydrogen were lost? Okay, so again, I like writing my numbers above it just so I can see where they're supposed to go. So again, 5 grams of hydrochloric acid, so that 5 grams is going to go there. We have 2 grams of magnesium, and then we have 3 grams of magnesium chloride. Okay, and then our answer, or our question rather, is asking for grams of hydrogen. Okay, so that's going to be our unknown. Okay, so again, I'm going to rewrite my problem algebraically. So our reactants, it's going to be 5 plus 2, and that has to equal the mass of our products also. So that's 3 plus our unknown mass, or that should be an X rather. Okay, so 5 plus 2 is going to be 7 equals 3 plus X. So again, algebra, subtract our 3 from that 7 and we get 4. So X equals 4. That means that 4.0 grams of hydrogen was lost in that reaction. Okay, so that's basically it for the law of conservation of mass. The important thing is that the mass of your products must be the same as the mass of your reactants. So you always want to set that as an equal sign. So wherever your yield symbol is, you can just turn that into an equal sign, okay? And then whatever the mass of your reactants equals the mass of your products. Okay, if you have any questions, feel free to ask.